All right, so we're going to continue our journey with logistic regression. We're going to start computing odds ratios and understanding how to interpret those, and also relating the odds ratio to the slope of the logistic regression model when it's in the loaded form. It does ask you to keep in mind here that the odds already are a ratio. So the odds ratio is something, it's a ratio of two different sets of odds, as opposed to the ratio that is the odds. All right, so the first example here is about a study involving migraines and whether this TMS treatment would work better than placebo. So the patients were randomly assigned to be either in the TMS or the placebo group. And then it was recorded 2 hours later whether or not they still had pain. So in this case, the explanatory variable would be the group that the subject was in, or which treatment they received, TMS or placebo. And the response would be whether or not the subject was pain-free after 2 hours. Both of those are categorical binary variables. Now you have this migraine.csv data file, and when you look at that in R, you'll see that it's already in summary form. It's like this table. The thing is that usually when we make a two-way table like this, the explanatory variable is what forms the columns and the response forms the rows normally. When you look at this data set in R, you'll see that it's just the opposite. Okay, so each group had 100 in it. 100 subjects. That kind of makes things easy in terms of interpreting, creating percentages. So in the TMS group, 39% of the subjects were pain-free after 2 hours. In the placebo group, it was 22%. And we have ways with statistics that we can compare those percentages to see if the difference is statistically significant. We can see that the TMS patients were more likely to be pain-free. But in addition to comparing the percentages, we can also compare the odds by creating this odds ratio. So note to self, success is being pain-free after 2 hours. So when we think about odds, we're thinking about the odds of success, generally speaking. So for example, the odds of success for the TMS group, that would be the ratio of the successes to the failures, so that would be 39 to 61. And if you get the decimal for that, it's 0.639. You should try it yourself to make sure you get the same thing. And then the odds of success for the placebo group is, again, the successes to the failures. And when you do that ratio, you get 0.282. And then the odds ratio is the ratio of each of those two odds. Right? So the odds ratio would be, for example, the odds of success in the TMS group in ratio with the odds of success for the placebo group, or 0.639 over 0.282. And if you do the math on that, you should get 2.27. So I have a little sentence down here. The way we can interpret that is saying the odds of being pain-free were over 2 times higher with TMS than with the placebo. Also, just note to self, if you were to, so we have this fraction odds for the TMS group over odds for the placebo group equals 2.27. If you multiply both sides by the odds of success for the placebo group, what you actually get is exactly what the sentence there says. In other words, the odds of success for the TMS group is equal to 2.27 times the odds of success for the placebo group. Now, FYI, we can write the ratio in the opposite order. So in other words, we could do the odds of success for the placebo group over the odds of success for the TMS group. And you could check, but if you were to do that, you should get 0.441. And so that would just mean that the odds of being pain-free in the placebo group are about 44% of the odds, or 0.44 times the odds of being pain-free for the TMS group. So we can interpret it either way. We can do the ratio in either order. We could also have looked at the odds of still having pain after 2 hours. So, basically any of the above is acceptable. It's just a question of how we interpret it. All right, and then I gave you some code here where you could ask the computer to calculate those things for you. Then we have this second example from the New England Journal of Medicine, where they were looking at the effectiveness of a drug called letrozole for postmenopausal women who had had breast cancer and had completed 5 years of tamoxifen therapy. So I invite you to actually pause the video and see if you can fill out this table for yourself. All the information you need is given here. So we're going to fill out the two-way table based on the description here in the example. So 7.2% of the 2,575 women who received letrozole suffered death or disease. So first of all, there were a total of 2,575 women in the letrozole group. If 7.2% of them suffered death or disease, you can do the math, but it should give you 185 women. And then if you subtract 2,575 minus 185, you should get 2,390. Then it says there were 2,582 women in the placebo group, and 13.2% of them suffered death or disease. So 13.2% of 2,582 should give you 341 women. And then when you do the subtraction, that leaves you 2,241 women in the placebo group who survived disease-free. And then you can create the totals column. Again, if you have any questions about how these numbers were arrived at, you can let me know. Now it says compute and interpret the odds ratio. It doesn't say what is considered success. What I would go by is the fact that the percentages we were given was for suffering death or disease. So even though that might seem counterintuitive, I would probably call that success in this case, because that's kind of what was reported out to us. So the odds of suffering death or disease for the letrozole group, that would be 185 successes to 2,390 failures, which gives 0.077. You can double check me on that. The odds of success for the placebo group, that would be 341 successes to 2,241 failures, and that's 0.152. So the odds ratio, which we can abbreviate OR, I typically take the higher value over the lower because I find that more natural in terms of interpretation, but you should get 1.97. So basically that's saying the odds of experiencing death, this is the interpretation, the odds of experiencing death or disease were almost twice as high in the placebo group, because that's the one that was in the numerator. So we're almost twice as high. In the placebo group. As in the letrozole group. Okay, and again, I gave you some code here, a little bit different than the previous, of ways that you can calculate this. Notice here, in terms of getting the odds, right? So in general, the odds are the probability. Remember, we go from probability to odds, probability over 1 minus probability. We had said pi over 1 minus pi, in this case p hat over 1 minus p hat. And then OR here for odds ratio, I'm putting placebo over letrozole.